So what we're going to do here is add and subtract unlike fractions. Unlike fractions are fractions with denominators that are not the same. So we need to come up with a common denominator, which is the LCM of the three numbers. So we can do it in different ways. So let's use the method 1. So start with the largest of the denominators, which is 12. And then you go 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36. If it's getting too long, then you should stop. But notice that when I look at 4, I can go 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. And we already found a common multiple. And then let's look at 6, and we know that 6 times 2 is 12. So the list is not very long. If the list is not too long, then this is a good method because we already identified our LCM, right? So always start with the largest of the numbers in the denominator, and then list the multiples. You can sometimes do it in your head. You can go 12 times 1 is 12. Does 4 go into 12? Does 6 go into 12? If it does, your list stops there. So now if we had to do it a different method, let's do it by division of primes, division by primes method. So division by primes method is dividing by primes. So that's an easy way to remember. Just divide by primes. What is the lowest prime? It is 2. 2 times 6 is 12. 2 times 2 is 4. 2 times 3 is 6. If a number is divisible by 2, you have to divide by 2. If it is not, we just leave it alone. So now we look at the list again. 6, 2, and 3. Now we know that 2 goes into at least one of the numbers. So we go 2 times 3 is 6. 2 times 1 is 2. And then 3. Now we look at the list again. 3, 1, 3. None of these numbers are divisible by 2. So we are done with the 2's. We start with the 3's. 3 is the next larger prime. So 3 goes into at least 1 for sure. And that ends our process. So what is the LCM? We look at these numbers and we go 2 times 2 times 3 equals 12. What's the other method? The other method is the prime factorization method, which means we break down the numbers into prime factors. 4 times 3 is 12. So that is 2 to the second power times 3 is 12. 4 is 2 squared. 6 is 2 to the 1 times 3 to the 1. So remember what we need to do once we've factored it completely and written it in exponential form. So we look at all the 2's in all the numbers, all three numbers, there's a 2. But we pick the largest of the 2's, which is 2 squared. We look at all the 3's in all three numbers. In the second one, it's missing, but that's not a problem. We just pick the largest of the 3's. And that is, again, going to give us 12. So we figured out that the LCM of 12, 4, and 6 is definitely 12. We did it in 3 different ways. Now, all we have to do is make each number, write it in its equivalent form with a denominator of 12. Now, the first one has a denominator of 12, so we don't need to worry about it. The second number, 4 times 3 is 12. The exact same number has to be multiplied in the numerator because we don't want to change 3/4. We're just writing it in a different way. 3 over 3 is a 1, so we have not changed the number, minus 1 over 6. Now 6 has to become a 12. What do we multiply 6 with? We multiply it with a 2. We multiply the numerator with a 2. And this is equal to 5 over 12 plus 9 over 12 minus 2 over 12. So this is equal to a common denominator of 12, 5 plus 9 minus 2, and that's equal to 9 plus 5 is 14 minus 2, it's 12. 12 over 12 equals 1. So the final answer is a 1. So what did we do? We looked at fractions that are not like fractions, which means the denominators are different. We need a common denominator. The common denominator is the LCM. We found the LCM by 3 different methods. Just as a review, we've done it in class, but then you have to keep reminding yourself how we find the LCM using different methods. Just keep reminding yourself. You can forget, so you have to remind yourself every single time what the 3 methods are. Just go over it in your head, even if you don't need it at that moment. So next we move on to the next question, 15 and 30. And right away, you can see that this would be a problem that we can do with the basic method, which is usually the crudest. You're listing multiples of 30. 30 times 1 is 30. We can basically stop there because we know that 15 goes into 30, because 15 times 1 is 15. 15 times 2 is 30. We found our least common multiple. What were we doing? We were listing multiples. So this is the basic crude method that does not work for larger numbers. Sometimes it is easy. So if you can look at the numbers in the denominator and say this would be an easy one to list multiples, only then do it. If not, the process is long and not an efficient method for larger numbers. Now let's look at the division by primes method. So we have 15. We're going to divide by primes. What are primes starting with 2? I can divide by 2 because 2 goes 15 times into 30. 2 doesn't go into 15, so we leave that alone. Since we have to divide by primes, I'm going to go in steps. The next larger prime is 15. 3 times 5 is 15. And then finally, 5 goes into both once, and then we have the LCM, which is 2 times 3 times 5, which is the same as 30, same as before. But we're just reviewing the 3 methods so we don't forget. Now, what is the next method? Prime factoring. So 3 to the 1 times 5 to the 1 is 15. 30 is 2 times 15, so it's 2 to the 1. Times 15, which is 3 to the 1 times 5 to the 1. Now we pick the largest 2. There's only 1, so that's 2. We pick the largest 3, and we pick the largest 5. So that also gives us 30. So clearly one method is enough to do it, but I'm just going over it so we can review this method. It's easy to forget if you're not using it consistently, or at least going over it once in a way. You could forget the method. So here, 4 over 15 now has to change to something over 30. And what do? 15 times 2 is 30. We do the exact same thing to the numerator. Now the next number has 30 in the denominator, so we don't need to change anything. 4 over 15 is the same as, in value, 8 over 30 minus 1 over 30. So this is equal to 8 minus 1 over 30, which is 7 over 30. If we do not have any common factors, then that is our final answer. 7 is a prime number that does not go into 30.